Hello students, now we'll continue with the next problems on Poisson distribution. So you can see a problem on the screen. I'll be solving this problem now. So I'll just read it out and then I'll start. The number of persons joining a cinema queue in a minute has Poisson distribution with parameter 5.8. So straight away parameter is given 5.8. Find the probability that first one, no one joins the queue in a minute. In a minute, no one joins the queue. Second option is two or more persons join the queue in a minute. Okay, so only in 1 minute, how many are joining and how many are not joining. Two options we have to find out now. So as I told you all, in binomial distribution, two parameters are there, but in Poisson distribution, only one parameter is there, that is lambda. Lambda value is nothing but it is given 5.8. So when only one parameter is there, you should come to know that it is Poisson distribution problem, and with the help of this we can solve. Okay, so first one, so let us solve. First one, no one joins the queue. Okay, so queue means a line. In the line in 1 minute no one has joined. Okay, so probability of x is equal to, we take is at 0. Okay, so now let us write the formula. Probability of x is equal to e raised to minus lambda, again lambda raised to x divided by x. So this is the formula of Poisson distribution. Okay, so now I'll just substitute e raised to lambda value is how much? Minus is in the question, in the formula only, minus 5.8. Again lambda value is how much? 5.8 raised to x is 0. What is x? 0. No one joins. No one means no one is there. It is 0. So 0 divided by 0 pollen. So e minus 5.8. This is 0. This is 0. That means it is e raised to minus 5.8. This is remaining. Now as I told you, Poisson distribution we have to see in the table. Okay, so chart is there. So behind your book, Poisson distribution and chart will be there. So it is here, Poisson distribution statistical table. So what is my value? 5.8. So where is 5.8 now? 5.8. 0 0 3 0 0 0 3 0. 5.8 here. 5.8. I hope you all can see on the screen. 5.8.0030. So 5.8.0030 is the value. So my answer is 0.003. This is the answer for the first option. Okay. Now second. I'll take it in the next page. Second option is what? Two or more join the queue. Two or more join the queue. Okay, two or more join the queue. So probability is what? Probability, what we are finding now? Two or more join the queue. This is more than sign, this is equal to sign. Two or more. So two is also included. Now, as I told you all, in Poisson distribution, I'll just write the formula first. E raised to minus lambda, lambda raised to x divided by x. Okay, this is a, okay. So in Poisson distribution only one parameter is there, two parameters are not given. If n value was given in the problem, we could have solved straightly, but here n value we don't know. Two or more than two means it is endless, we don't know the end of that numbers, so we can't solve this problem. 2 3 4 5 6 7, up to which problem we should stop we don't know, it is infinite numbers. Okay, so that is the reason we follow complement method. Complement means opposite. whatever numbers are remaining, that numbers we take and solve. So probability of x is equal to probability of 0 plus probability of 1. Okay, these are the two which we have to solve. Inside 0, always it starts from 0. So 0, 1, 2 and more than 2 is this side. Opposite of that remaining is what? 0 and 1. So 0 and 1 I have taken here. Now we can solve only these two, but we have to follow which one? We have to follow complement method. So 1 minus probability of 0 plus probability of 1 we have to solve now. Now same formula you'll have to apply. So first one is e raised to whatever is your lambda value is 5.8, then again 5.8 raised to x is 0, exponent plus again e raised to minus 5.8 lambda, again lambda is 5.8, now x value is 1 divided by 1. So these are the two things which I am solving. Okay, so this simple method to solve is 1 minus this and this gets cancelled. So e minus 5.8. Here when that gets cancelled, here don't write 0 but always write 1. Okay, 0 1 is 0 this. Okay, always remaining is 1 plus when you remove this common e minus 5.8. Okay, what is remaining here? 5.8 raised to 1 means 5.8 and 1. So now just remove e minus 5.8 common. We have removed in both this which is common e minus 5. So remove it outside the bracket, and in bracket what will remain? 1 plus 5.8 will remain. Okay, I hope you all have understood. So I have removed this and this which is both common in both this. I have removed it outside. Then 1 plus 5.8 is remaining is equal to 1 minus e minus 5.8. In bracket my answer will be 6.8. Now 1 minus in the table e minus 5.8. What was the value I have seen in the table already? It was 0.003. You multiply it by 3.8. Okay, how I got this 0.003? I saw it in the table. Then is equal to 1 minus 6.8 into 0.003. My answer will come around 0.0204. So minus 1 minus this if you do, it will come to 0.9796. So this is my answer to the second one. So remember, in Poisson distribution, always apply complement method. Complement method means 1 minus the remaining numbers or opposite of the question which is asked. 2 or more join in the queue. Opposite of this is 1 and 0. So 1 and 0, 0 and 1 I have solved. So this is the method. So just practice this, you will understand. So this is the first problem which I have solved now. Now let us go with the next problem. I'll just read it out and then I will tell you. Okay, so just see here. Average number of telephone calls at an exchange between 10 a.m. to 10:10 a.m. So 10 minutes difference is there. So what is the average call they are finding out is 4. Okay, 4. The average number of telephone calls at an exchange between 10 a.m. and 10 a.m. is 4. So find the probability that on a randomly selected day there are 2 or more calls between 10 a.m. a.m. On how many days of the year would you expect 2 or more calls during the time gap? So this last sentence we have to calculate afterwards. Before that we have to find the probability that on a randomly selected day there are 2 or more calls between. What we have to find out now? 2 or more calls. Okay, 2 or more calls. Same previous question how it was. So second problem, given parameter is what? Lambda. What is lambda now in this? Lambda average. Okay, the average number of telephone call at an exchange between 10 points, how much? 4. So my lambda value is 4. My formula is, probability of x formula is how much? E raised to minus lambda raised to x divided by exponent. This is my formula. Okay, so what I have to find out now? Probability of x, 2 or more calls. 2 or more calls between 10 to 10, 30, 10 am. So 10 minutes difference is there. So again, 2 or more calls, n value is missing. We don't know what is the L value. So what we do? We apply complement method. So opposite of this is what? Is equal to 1 minus inside number remaining is 0 plus probability of 1 is remaining. Same previous problem what we had done, same we have to do here. Only value of lambda is changed. So 1 minus e raised to lambda, then 4 raised to 0, 0 is x value 0, 0 dash plus e raised to minus 4, then 4 raised to now 1 divided by 1 pollen. This is the solution which I have to do. 1 minus this 0 and this is 0. So e minus 4, 1 is remaining here, plus e minus 4, 4 is remaining here. Okay, so let us remove common now. E minus 4 will remove common outside. So in bracket 1 plus 4 is remaining now. So now let us go through the table. In the table, value of minus 4 we'll see. So value of minus 4, Poisson distribution table, 4, 0.0183, 0.0183. Okay, so this is the value of lambda minus 4 in the table. Then 1 plus 4 is how much? 1 plus 4 is 5. So multiply this now. 1 minus, after multiplying it comes around 0.0915. Then 1 minus this 0.9085. This is my answer. Okay, so in this way, complement method we have to apply and we have to solve the problem. Okay, so this one was regarding the second problem. Next, now we will do one more problem. I'll read out. On an average, a typist makes 3 mistakes while typing one page. What is the probability that a randomly observed page is free of mistake? Among 200 pages, in how many pages would you expect mistake? See here, on an average, a typist makes 3 mistakes. What is this 3 now? This is the lambda value is equal to 3. While typing one page, what is the probability that a randomly observed page is free of mistake? So whenever we take a page randomly select, it is free of mistake. Among 200 pages, so total 200 pages, in how many pages would you expect mistakes? So 200 pages we will do it. Okay, we will calculate it afterwards. So previous problem, one more question was asked. So I'll just continue it. So 2 questions were there, sorry. I'll just complete this. Find the probability that on randomly selected there are 2 or more call between. So this we have done. Now On how many days of the year would you expect two or more calls during the gap they have here? So number of days is equal to, in a year how many days are there? 365 days. Into whatever answer you have got, you have to just multiply it. So after multiplying, I got 332. So 332 days, there may be more or two or more calls between 10 to 10 a.m. Okay, so just only one thing which we had to do and which we forgot in this problem was number of days they have asked, number of days in a year. So 365 days are there in a year, into whatever answer I have got now. If you multiply both this, you will get the answer. Okay, now let us move to the problem. So three mistakes in this problem also same is asked. Among 200 pages, in how many pages would you expect? So last whatever you solve the answer, multiplied by 200, you will get the answer. So now I'll just solve this problem. So three mistakes are there. What have they have told here? So lambda value in this problem is 3. Three mistakes are there. What is the probability that the randomly observed page is free of mistake? Free of mistake means no mistake. What we have to find out now? Probability of x is equal to free of mistakes. So free of mistakes means no mistakes. What it is? Probability is 0. Okay. Now one option is this. So let us solve first one. So straight away apply the formula e raised to minus 3, 3 raised to 0 and then pollen dash. Here no need of complement, right? Because free of mistakes. Straight away they have told that there is no mistake. No mistake means 0. And then this and this is can cancel, only e this will remain, and from the table minus 3, when I see in the table it is 00498. This is my answer. Okay, we have solved first part of the question. Next part, what they have asked, among 200 pages, in how many pages will you expect mistakes? First they asked free of mistakes means no mistake. Second option they have asked has mistakes. Probability of x has mistakes. Has mistakes. So how many mistakes you have? We don't know. N value is missing. So probability of x, always we follow what? Complement method. 1 minus opposite of has mistakes is no mistakes. Always you take the opposite one. So 1 minus no mistakes means probability of 0. So probability of 0 already we have solved and we have got the answer how much. So straight away you can write here p minus 0.0498. So after minus I will get my answer as 0.9502. Now in 200 pages how many mistakes are there? Therefore in 200 pages number of mistakes is equal to 200 into this value 0.9502 mistakes value. Okay, so after multiplying my answer comes around, it is it comes around 190. Okay, 190. So this is the next problem. So hope you all have understood all the three answers. In next class I will continue with some more problems on Poisson distribution, and then I'll move to normal distribution. Thank you.